Welcome to Senior High School Math Series. On this video presentation, let us discuss solving systems of nonlinear equations under PreCalculus. A system of nonlinear equations is a system of two or more equations in two or more variables containing at least one equation that is not linear. Recall that a linear equation in two variables can take the form ax plus by plus c equals 0, where a, b, and c are real numbers, and a and b cannot be both 0. Any equation that cannot be written in this form is nonlinear. An example of a system of nonlinear equation is an equation of a parabola and an equation of a line. There are three possible types of solutions for a system of nonlinear equations involving a parabola and a line. Number 1, there is no solution when the parabola and the line does not intersect. Number 2, there is one solution when the line is tangent to the parabola. And number 3, we have two solutions when the line intersects the parabola at two distinct points. The substitution method we use for linear systems is the same method that we're going to use for nonlinear systems. We solve one equation for one variable and then substitute the result into the second equation to solve for the other variable, and so on. Let us have an example. Solve the system y is equal to x squared plus 1 and x minus y plus 1 equals 0. For our suggested solution, let us label the equation. We have equation 1 for the linear equation and the equation of the parabola as equation 2. Using equation 1, we're going to rewrite as an equation of y in terms of x. So from x minus y plus 1 equals 0, we have y is equal to x plus 1. Next, we're going to substitute y is equal to x plus 1 to equation 2. So from y is equal to x squared plus 1, we now have x plus 1 is equal to x squared plus 1. We have x squared minus x is equal to 0. To solve for x, we're going to solve this quadratic equation by factoring. So we have x times the quantity x minus 1 is equal to 0. Equating each factor to 0, we have x equals 0 and x minus 1 is equal to 0. Then the solution to the quadratic equation are x equals 0 and x is equal to 1. Now let us substitute the result to either the equation of the parabola or the equation of the line. Let us use the equation of the parabola. If x is equal to 0, we have y is equal to 0 squared plus 1, then y is equal to 1. Then one solution is the ordered pair 0, 1. Next, if x is equal to 1, then we have y is equal to 1 squared plus 1, then y is equal to 2. Then another solution is the ordered pair 1, 2. Hence, the solution set to this system of nonlinear equation are the ordered pairs 0, 1 and 1, 2. To check whether our solutions are correct, Then we're going to substitute each ordered pair to the system of nonlinear equation. Recall that our solutions are 0, 1, and 1, 2. Since we solve for the value of y using the equation of the parabola, we're going to check the solution by substituting these ordered pairs to the equation of the line. Let's start with the ordered pair 0, 1. Then for the equation of the line, we have 0 minus 1 plus 1 equals 0. And this is 0 on the left side. Hence, the solution is correct. Next, at the ordered pair 1, 2, then we have 1 minus 2 plus 1 equals 0. 1 minus 2 is negative 1 plus 1. We have 0 is equal to 0. Therefore, the ordered pair solutions are correct. Another way to check the solution is to graph the parabola and the line and see whether the two graphs intersect at 0, 1 and 1, 2. Another example of a system of nonlinear equation involves the equation of a circle and equation of a line. There are also three possible types of solutions for a system of nonlinear equations involving a circle and a line. Number 1, there is no solution when the line and the circle does not intersect. Number 2, there is one solution when the line is tangent to the circle. Number 3, there are two solutions when the line intersects the circle at two distinct points. Let us have another example. Solve the system x squared plus y squared equals 5 and 3x minus y equals 5. Again, for our suggested solution, let us label the linear equation as equation 1 and the equation of the circle as equation 2. And from equation 1, let us rewrite as an equation of y in terms of x. So from 3x minus y equals 5, we have y is equal to 3x minus 5. Then we're going to substitute y is equal to 3x minus 5 to equation 2. So we will have x squared plus the quantity 3x minus 5 close quantity is squared equals 5. So we have a quadratic equation again in terms of x. Let us rewrite into its standard form. Squaring the binomial 3x minus 5, we have x squared plus 9x squared minus 30x plus 25 equals 5. Combining similar terms, then we have 10x squared minus 30x, and subtracting 5 from both sides of this equation, we'll have plus 20 equals 0. Notice that we can simplify the equation by dividing all terms by 10. Then we have x squared minus 3x plus 2 equals 0. From here, let us solve the quadratic equation by factoring. So we have two binomials in x. The second term would be two numbers whose product is positive 2 and whose sum or difference is negative 3. Then we have negative 1, negative 2. So x squared minus 3x plus 2 equals 0 can be rewritten as x minus 1 times x minus 2 equals 0. Solving for x, we equate each factor to 0, so we have x minus 1 equals 0. Adding 1 to both sides, we have x equals 1. For the other factor, we have x minus 2 equals 0. Then we have x is equal to 2 by adding 2 to both sides of the equation. This time, let us solve for y. From equation 1, we have y is equal to 3x minus 5. Then we can solve for the value of y by substituting each values of x to the equation of the line. If x is equal to 1, then we have y is equal to 3 times 1 minus 5. Hence, y is equal to negative 2. And if x is equal to 2, then we have y is equal to 3 times 2 minus 5. Then we have y is equal to 1. When x is equal to 1, we have the ordered pair 1, negative 2. And when x is equal to 2, we have the ordered pair 2, 1. To check our solution, we will again substitute the ordered pairs to our system of nonlinear equations. Recall that our solutions are the ordered pair 1, negative 2 and 2, 1. Since we solved for the value of y using the linear equation, we're going to check using the equation of the circle. Let us begin with the ordered pair 1, negative 2. So we have 1 squared plus negative 2 squared is equal to 5. 1 squared is 1, negative 2 squared is 4, then 1 plus 4 is equal to 5. 1 negative 2 is indeed a solution to the system of nonlinear equations. Next, at ordered pair 2, 1, we have 2 squared plus 1 squared is equal to 5. 2 squared is 4, 1 squared is 1, and 4 plus 1 is equal to 5. Both 1 negative 2 and 2 1 are solutions to the system of nonlinear equations. Again, another way to show whether the solutions are correct is to graph the system of nonlinear equations. We will see that the circle and the line intersect at points 2, 1 and 1, negative 2. Another example of a system of nonlinear equation involves a circle and an ellipse. There are 5 possible types of solutions for a system of nonlinear equations involving a circle and an ellipse. First, there is no solution if the circle and the ellipse does not intersect. Second, there is one solution when the circle and the ellipse are externally tangent to each other. Next, there are 2 solutions when the circle and the ellipse intersect at 2 points. Another, we have 3 solutions when the circle and the ellipse intersect at 3 points. And last, there are 4 solutions when the circle and the ellipse intersect at 4 different points. Let us have another example. Solve the system x squared plus y squared equals 26 and 3x squared plus 25y squared equals 100. This time, for our suggested solution, we're going to use the elimination method that we usually use in linear systems. First, let us label the equation of the circle as equation 1 and the equation of the ellipse as equation 2. To use the elimination method, we're going to manipulate the equations in such a way that we can eliminate one variable and solve for the other variable. In here, we're going to eliminate x squared by multiplying equation 1 by 3. After eliminating x squared, we're going to solve for the value of y. And after solving for the value of y, we will substitute these values to one of these equations to solve for the other variable x. Let us begin. So we will have 3 times equation 1 minus equation 2 to eliminate x squared. Multiplying the equation of the circle by 3, we have 3x squared plus 3y squared equals 78. And then subtracting the equation of the ellipse term-wise, 3x squared plus 25y squared equals 100, we will have 3x squared minus 3x squared is 0. 3y squared minus 25y squared is negative 22y squared. And 78 minus 100 is negative 22. Dividing both sides of this resulting equation by negative 22, we have y squared is equal to 1. Then getting the square root of both sides, we will have y is equal to positive negative 1. Now that we have values for y, we can use this to solve for the value of x. Let us choose the equation of the circle. If y is equal to 1, then we have x squared plus 1 squared equals 26. 1 squared is 1, and subtracting 1 from both sides of this equation, we have x squared equals 25. Getting the square root of both sides, we have x is equal to positive negative 5. Then we have two solutions already. That is the ordered pairs 5, 1 and negative 5, 1. Next, if y is equal to negative 1, we have x squared plus negative 1 squared is equal to 26 for the equation of the circle. So we have x squared plus 1 is equal to 26. Then x squared is equal to 25. Getting the square root of both sides, we have x is equal to positive or negative 5. Again, we have the ordered pairs 5, negative 1 and negative 5, negative 1 as the solution to the system of nonlinear equations. To check whether the solutions are correct, we substitute the ordered pair solutions to the system of nonlinear equations. Since we solve for the values of x using the equation of the circle, we can check by substituting the ordered pair solutions to the equation of the ellipse. Or we can also graph the two equations and see if they intersect at the ordered pair solutions. For another example on solving system of nonlinear equations, we have a video presentation that was uploaded prior to this one. If you haven't seen it, the link is on the description of this video. That will be all. Thank you for watching. Please subscribe for more math lessons.